Hi class, let's take a look at problem 4. And in problem 4, we have the same scenario in terms of a system of inequalities. And we're dealing with an intersection for the first one. And an intersection for the first one. And then a union for the second one. Off the back, we have to be a little bit careful. Notice that the slope of these two is going to be the same. So let me label this one as 1, and then we'll put number 2 here. Okay, and let me just do all the information for number 2. So this is going to be y is equal to x minus 6. So the y-intercept is 0, negative 6. And the slope is 1 over 1. Let me box this in. Then for the second one, actually the first one, in this situation, let me put the info here. This is going to be y is equal to x plus 7. So y-intercept is 0, 7, and slope of 1 over 1. And we do have one that says greater, the other one that says less than or equal, actually greater than or equal on those two. And let me put the dots. So for the first one, we're going to go at 0, 7. So 1, 2, 3, 4, 7 is here. Let me count them again. 1, 2, 3, 4, 5, 6, 7. And then we're going to be doing a slope of 1. So technically 1 and 1. And let me put the second dot, which is technically there. Let me do the second inequality. 0, negative 6. So 0, negative 6. Let me make it a little bit larger. And then also 1, 1 in the slope. So 1, 1, it's going to be there. Okay, let me input both of the lines. And both of the lines are going to be solid. Okay, so here's the first one. Let me make it a little bit thicker. I think that's perfectly fine. And let me copy this and see if it lets me paste it, and then we can just change the color. Okay, so let's take a look at the parts of the inequality that we would be technically shading. So notice that on the first one, it's greater than or equal. So blue line, it's going to be above here. And then the second one, which is the green one, we're looking at a statement that says less than or equal. So in this situation, it's going to be below. Now, they're asking for the intersection. So in this case, the intersection is not going to have a solution. So we won't be doing any shading. We would just put the boundaries. We do have to mention that this is a no solution. And we do have to go back and make the lines technically dotted to indicate that they're not part of the solution. If we don't make the lines dotted, it may give the impression that the solution is the line, but it's not. The only reason that we actually write them as solid is because of the shading and the possible overlapping. So in this case, this would have been a graph with no values dotted. So we're just gonna express that by technically circling that portion, but we do have to mention that this is a no solution. They do want us to find the intersection, so technically no values get shaded on this one. Let me pause the video and then technically transfer this over. Okay, so I added those two lines, and notice I put them as solid because the actual inequalities are greater than or equal or less than or equal. So when you're doing the union, you are merging solutions. So in this case, for the union, we would simply shade above this line and technically below this line. And the only portion of the plane that doesn't get shaded, it's this middle portion. Keep in mind that the lines will continue on to infinity, but it's just sufficient to shade above it and below it. This would be our solution set. The previous one, since technically there's no overlapping, we wouldn't have any value shaded, so that's why we had to go back and make those lines dotted. Now let me show you how these look with technology, and you can see here one of them, in this case the blue one, we're shading above it, green one we're shading below it, but there's no point where they're overlapping. The overlap of the two solutions, it's what gives you the solution of the intersection. So in this case, this is technically a graph with nothing shaded. We do leave the coordinate points there because we needed that for the line. And in the union, you do put both of those together, which is what this graph represents using technology. It's technically including all the coordinate points in here and all the coordinate points there. That's actually it for this one. It's a little bit tricky. We just have to do a little bit of analysis in terms of the meaning of the union and intersection. Let me go back to the basic definitions. Once again, when we're dealing with an intersection, is all the places on the plane where one solution and the second solution happens to overlap. And the union, you're putting both of those together as one. So that's why on part A, we had no overlapping of values. So technically this is one of those of the empty set. A no solution is sufficient. If they were to ask for the set, in this case, let me just write that the set, it's technically the empty set. And that's just another way of expressing this is a no solution problem.